Okay. So, Javed, just for your understanding purpose, I'm just introducing myself again. So, this is Prasad. I'm having 20 years of professional work experience, and I worked as an architect. So, currently, to take care of my company and also to take care of my institute, I just resigned like 2 months back. That's about it. And I teach DevOps, AWS, .NET, data engineering, data analytics, all that. Yeah, so this demo is all about DevOps and AWS. So let's start the demo. Yeah. So yeah, if at all, if you have any questions in between, yeah, you can definitely raise and ask me a question, not a problem. Right. So yeah, most of you are working professionals. So definitely when you are working for an organization, you work for a project. Okay. Before that, whenever you are learning any technology or any process, it is important to understand why is it required. So why DevOps and cloud or AWS is important to understand. So let's try to understand that. So when you are working for an organization, you work for a project. Now this particular project, you actually get it from some client. Client is also some other organization. Generally, client does not allocate or assign a project to one particular organization directly. Client would be verifying n number of organizations and based on some considerations, right? Okay, so then they'll be choosing one of the organization. My point is on what basis they allocate or assign a project to one particular organization. Okay, so let me just open one small PPT. Organization. Okay, if you're not talking, you can please go on mute, and if you want to talk to me, you can unmute and talk to me. Yeah. So any organization look for cost, right? Cost effective. Okay. If someone is little cheaper, they'll incline towards that. So that is very important. So, and just because you are little cheaper, it doesn't mean that you can deliver it whenever you want. That's not the point, right? So definitely fastest delivery is an important factor when they are assigning the project to any one particular organization. And at the same time, they look for quality. It doesn't mean that like you have delivered a product which can't be used, right? Definitely they look for quality as well. And if you are maintaining the project, high availability matters a lot, meaning your application should be always be running, up and running, and the very quick response you should be getting it because we are in competitive market. So definitely high availability matters a lot. Okay, so this is what any organization look for. Okay, cost effective, fastest delivery, quality, and high availability. So each and every organization look to achieve these four, but for some reason it is not happening for all. Okay, so now what exactly we do is we actually divide an organization into two teams: development team and operational team. Who comes under development team? Developers, testers, project managers. Whoever is responsible for delivering the project, they come under development team. Then who comes under operational team? Okay, these guys are admins. They actually own the environments. So I'll explain what is an environment and all the environments as well. I'll come to that. But these team members, generally they own environments like test UAT and production environments, and they are responsible for delivering, like deploying the application into those environments and monitor it. Okay. So someone else joined. So Mohit, I just started. Okay. So please follow. So if at all you are having any questions, you can raise and ask me a question. Okay. Yeah. Fine then. So Under the development team, as I mentioned, there will be developers, testers, project managers, whoever is responsible for delivering the project, they come under development team. Now, what my intention is, on day-to-day basis, these two team members would be facing some problems. If we can able to understand the problems faced by these two team members and provide solutions to those problems, then we can achieve these four. Okay, because of those issues, they are not able to achieve these four. But if you can able to identify those problems and provide solutions to those problems, then we can achieve these four. That's what the main idea is. Okay, so let's try to understand those. Before we try to understand, there are few technical terms I'll be keep using in this particular demo. So let us try to understand those technical terms. Then we'll get into the this problems faced by development team members and operational team members, and we'll also understand in the process the tools and the services which we will be learning as part of this particular course. Okay, fine. So there is something called development and deployment. Development and deployment. So what is a development? So development meaning you get some requirements from the client and you make it work in the developer system is actually called development. Okay, so deployment meaning, yes, it is running successfully in my system, but I wish to run it on some other system or set of servers or set of systems so that that application can be usable by others. Okay, so that is deployment. Okay, so in this process, all this we will be doing it, and the development you actually plan, design, code, build and test and commit, all that you will be doing it. But when it comes to the deployment, you actually package it and deploy into the related system or a set of servers, or we call it as environment. I'll come to the environment part, and you'll be keep monitoring it, and actual users will be using it. Okay, so that's the deployment part, development and deployment. Running the application in the developer system is actually called development. Running the application in some other system or a set of systems or a servers or an environment is actually called deployment. Right. So then the next one is actually environments. So what is an environment? So set of systems or a servers, we actually call it as environment, but in that particular set of systems or a server, you actually deploy your application. And the purpose of deployment is set of users will be using that particular environment. So you will have environments like dev environment, test environment, staging environment, and production environments. So in the dev environment, only developers will be using it. You can see the purpose and the who uses it. So only developers will be using the development environment. Okay. So then test environment will be used by QA testers. Okay, they do the functional testing and performance security testing, all that they'll be doing in the test environment. Then the UAT environment, it is user acceptance test. Okay, so client would be testing the application in the UAT environment. Okay, business users, they'll be testing in the UAT environment. Then the production environment, actual users will be using this particular environment, which is a production environment. Now you understood what is development, what is deployment, and what is an environment, and different types of environments generally for an application which we will be using it. Okay, now let us get into the issues faced by development team first. Okay, dev team and operational team. First, let's try to understand the development team problems. Okay, then we'll move to the operational team problems. Then we provide solutions. Fine. When I talk about development team, definitely there will be developers under this particular team. Okay, what is the job of the developers? Generally, they write some code. That code we call it as source code. Okay, so irrespective of the technology, it can be .NET, it can be Java, it can be Node.js, anything, doesn't matter, but they write some code. Okay, it will be in the forms of files and folders, right? Now, where do they store that particular code? Initially in their system, in the developer system. Now, if they keep that particular code only in the developer system, then you will have two problems. One problem is if that system get crashed, you will be losing the code. That is one issue. And the second issue is at some point you need to integrate the code, meaning your code, I need it, my code, you need it, because we are all working for one project as developers. Then you need to, at some point, you need to integrate the code. When you are trying to integrate the code, you shouldn't be asking other person, give me your code, and vice versa shouldn't happen, because we work on agile methodology. I'll come to that anyway. So we are not supposed to waste the time. Okay. So that is the reason what we'll have to do is we need to keep this particular code in a server with the help of version control system. So we are using Git as a version control system. With the help of Git, you are actually keeping the code into the server so that if your system get crashed, you can always take the code from the server, and all the developers will be keep pushing the code into that particular server. So when you need other developers code, the project code, you always take it from the server with the help of Git. And there is also another advantage by using the Git, which is like you get the history of that particular code. Okay. In detail anyway about the Git and all, you will be learning in the regular sessions, but with the help of Git, we are actually keeping the code in the server. Now you have the code in the server, which is project code. Now, deploying the application into the dev environment is the responsibility of the developers. Now, I'm not talking about like once we introduce the DevOps process. Before that, if DevOps process is not introduced, then what exactly happens? Okay, deploying the application into the dev environment is the responsibility of the developers. So they will be deploying the application into the dev environment generally once in a day. The reason is they are developers. Their core job is actually to develop the code, not to deploy the application. Okay, that's the reason they'll do it once in a day. So let's say they are trying to deploy the application once in a day in the evening around 5:30 or 6 p.m. and then they leave office. If they are doing it in that way in the evening 5:30 or 6 o'clock, if any issue comes while deploying the application into the dev environment, then everyone in the team should sit and fix that particular issue. Why everyone in the team? Why not only one or two? The reason is from morning to evening, multiple developers push the code into the Git, right? So we don't know who has introduced that particular issue. It may be anyone. So that is the reason everyone in the team should sit and fix that particular issue, and they are supposed to fix that particular issue on the same day. They shouldn't come on the next day and try to fix that particular issue. Why is the question. So why not the next day they come and fix that particular issue? The reason is we work on agile methodology. That's important. Now let's talk about what is an agile methodology. Then we'll come back to this particular issue. Okay. So when you get requirements from the client, you directly don't start coding it, right? If you directly start coding it, what will happen? You'll end up having so many issues and success rate will be very less. So that's the reason you follow something called SDLC, Software Development Lifecycle. In this SDLC, you will have phases called requirement gathering, analysis, design, development, testing, maintenance, all that. And these phases are self-explanatory, but let me explain anyway. So in the analysis, in the requirement gathering phase, you gather requirements from the client. Then in the analysis phase, you analyze the requirements. Then after that, you design it. Design meaning it is not the web design. It is actually architecture of the project. Who does that? Architect will be doing it. After this, you will get something like HLDs and LLDs. So that is high level design and low level design. Using that, developers will be developing the application. and then it goes to the testing, then it goes to the maintenance. Fine. Now, these phases can be implemented by using multiple methodologies, and two of the popular methodologies are waterfall model and agile methodology. Okay, so let's first discuss about waterfall model, then we actually get into agile methodology. There are some disadvantages or limitations by using waterfall model. That is the reason we are actually using agile methodology. But what exactly waterfall model does? Waterfall model says you execute SDLC phases one after another. That means you completely finish one phase of the SDLC, then only you move to the next phase of the SDLC. So let's say there are 100 requirements and you gather all the requirements, then you would analyze all the requirements. So then you design for all requirements, then you develop all requirements, then testing all that. Okay, now one phase fall into the next phase. One phase would be the next input for the next phase. So according to this, when exactly you will be completing the testing phase? It comes last, right? Okay, so till the testing is not complete, okay, so you will not be in a position to take a feedback from the client. Fine. So let's say after around 10th month or 11th month starting, you are in a position to like complete the testing phase. Now at that time you go to the client and ask for a feedback. Actually, let's say the duration of the project is 12 months and you have completed 10th month end or 11th month beginning. Now at that time you go to the client and ask for a feedback, and if client says this is not what I have expected, I need these changes. If those changes are minimal, you can accommodate those changes. If those changes are very major changes, then you will not be in a position to accommodate those changes. Then what will happen? This project will become a failure. See, you are taking a feedback in the end, so you don't have time, and you might have spent all the money whatever you received it actually from the client. So that is the reason there is only 30% success rate by using waterfall model. So that's the reason what people does is actually people are actually working on agile methodology. What exactly agile says? Instead of taking all requirements at a time, take few. For example, total 100 requirements, out of that you take like 10, 5, 15, whatever, and you try to execute these requirements in short duration. And in this particular duration, you follow all SDLC phases, meaning you gather, you analyze, you design, you develop, you test it, but only for the requirements which we have taken for this particular duration. Okay, so that duration we call it as sprint. The duration most of the cases will be 2 weeks, and 3 or 4 weeks are almost a month. So in this particular period, what do you do? As I mentioned, you follow all SDLC phases. At the end of that particular period, you go to the client and ask for a feedback. If client says this is not what I have expected, I need these changes, you will be in a position to accommodate those changes. The reason is you are not taking the feedback in the end of the project like 11th month or 10th month or whatever. You are taking a feedback every 2 weeks. Very often you are taking feedback. So you will be in a position to accommodate those changes. For example, let's say you have taken 100 requirements, total 100 requirements. So these we call it as backlog items in Agile. Then out of 10, out of 100, 10 are taken for this particular sprint. The duration we call it as sprint, right? So out of 10, 8 are agreed by client and 2 are not agreed. So 8 we don't need to work on. 8 are already accepted by the client, and remaining are 92 because 2 are not accepted. So remaining are 92. For the next sprint, you will be taking again 12, 15 or something from this particular 92, and then you'll be working on next sprint. Okay, so this is how the cycle goes on. At the end of the project, you will have to complete all the requirements, and requirements maybe keep changing since we are working on agile methodology. So when you say agile, so I said 2 weeks. Most of the time we work on 2 week sprint. So when you say 2 weeks, it's 14 days. So weekends we don't work, then it becomes 10 days. Then 1 day is actually required to take a feedback from the client. In some cases only there will be a BA and then they will be taking the feedback. Otherwise, the entire team will be involved. So then 1 day will be losing there. It becomes 9 days. 1 day is actually required for integration test. Then it becomes actually 8 days. Half a day is required for planning the sprint. What are all the requirements which we need to take it for this particular sprint? Okay. So then we have only 7.5 days left. Very, very limited time. So within this 7.5 days, we'll have to execute all the requirements which we have taken for that particular sprint. Okay, so very, very less time. Now let's come back to the issue faced by development team members. As I mentioned, they were taking the builds in the evening before they leave office. If any issue comes, everyone in the team should sit and fix that particular issue. And if they are not doing it, if they come on the next day and try to fix that issue, generally what will happen every day morning, everyone should take the latest code and work on it. Now there is an issue in that particular code. And if you are fixing on the next day, then we are losing the time. We are into agile. We have only 7.5 days. We don't have time to fix it and then work on it. So that is the reason everyone in the team should sit and fix that particular issue on the same day. Okay. Now let's say they were there in the office till 9:30 p.m. or 10 p.m. The very next day, they'll come late to office, right? If not like 2 or 3 hours, at least 1 hour late. If that is happening, what will happen? Then this will not happen. Okay, why this will not happen? See, they are coming late to office, which will not happen fastest delivery. So if there are 6 developers, if each person is actually coming 1 hour late, then we are losing 6 hours there. If this is happening one day, we can adjust. See, 6 hours is like one man day effort. We work maximum 9 hours per day, and then we are losing like 80% of one man day effort. If this is happening one day, we can adjust. If this is keeps happening, then what will happen? This we can't deliver. Forget about fastest delivery, not even a delivery. That is a problem faced by development team members. Okay, now that is only a problem statement. Fine. Now we need to find a solution. We'll come back to the solution, but first let us try to understand the problem faced by operational team member. As I mentioned, these members are admins. They own the environment like test, UAT, and production environment, and they are responsible for deploying the application into those environments. But even though they are responsible for deploying the application into those environments, there are some configurations developer only would be knowing it. So that's the reason they both sit together and they'll be writing the instructions saying like this is how it should get deployed into those environments. Using that instructions, operational team member would be deploying it. While deploying, if they encounter any problem, then operational team member tries to approach development team member. Now development team member says, I am into Agile. I am working on my own tasks. As soon as or whenever I complete that particular task, I'll assist you. If that whenever comes quickly, not a problem. Otherwise, again the same problem. The client would be watching. It's the application is not getting deployed on time. Then you get an escalation. Okay. Actually, it is no one's fault. Both are trying to work for a project, but still it is not happening. Okay. Again, it comes down to the delivery only. Okay. So this is a problem faced by operational team members. Now we'll have to find a solution for these two problems. Now the solution is if the development team members and the operational team members communicate and collaborate, communicate and collaborate with the help of automation tools. With the help of automation tools, then you get a solution. That is DevOps. Okay, the communication and collaboration between the development team members and operational team members. Okay, with the help of automation tools. You can see in the bottom all the automation tools. Okay, anyway, we'll touch each one of them. I'll come to that. Okay, so the communication and the collaboration between the development team members and the operational team members with the help of automation tools is called DevOps. You might have seen this one, right? So this is DevOps. Okay, yes, theoretically it is fine. So what exactly development team members are doing, you understood here. I mean, you can see there, write the code, build the code, test the code, commit the code, all that. Then operational team members, what they do, you're seeing there. Okay, but it should happen with the help of communication and collaboration. Then we can achieve the success. Okay, fine. For me, DevOps is all about in the entire project lifecycle, if anything is a repetitive task and if that can be automated, then you can save the time and that would be useful for Agile. That is for DevOps. That is DevOps. Okay, fine. Now, theoretically, it is fine as I mentioned, but practically, how do you achieve it is the question. Fine. So, practically, how do you achieve it? So, first issue, what is the problem faced by development team members? They are trying to build the application in the evening before they leave office. But let's try to understand what is build first. Okay. So build actually consists of, see, first of all, deployment is equals to build plus release. Remember that. Build plus release. Okay. So then what is a build? In the build, you clone the code, you compile the code. What do you mean by compilation? Converting your source code to mission understandable language is compilation. So then after that, you generate the package. Then if there are any unit testing needs to be done, you do it. I'll explain what is unit testing little later. Then you package it. You're not deploying it, but you just package it. But into the dev environment can be deployed. Okay. So that is actually build. Fine. Now what I am trying to say is, so there are 6 developers and you are actually trying to build the application in the evening before you leave office or deploy it into the dev. But don't do that. Each time developer push the code, you try to build the application. Okay. Each time developer push the code. Let's say there are 6 developers and each person is actually average pushing 3 times a day. And all these times, if any one of the developer tries to build the application, then if any issue comes while building the application, if that particular person informs to everyone saying that there is a problem in that particular build, then what will happen is, let's say I am one among them. I am pushing the code at 11 a.m. Till 11 a.m. everything was working as expected. And I push the code at 11 a.m. And if any one of the developer tries to take a build at that time, if they encounter any issue, if that particular person informs to everyone saying that there is a problem in the build, then everyone knows till that time it was working. After I pushed it, it stopped working. Then I am the responsible person to fix that particular issue and others can focus on their own work. That's the idea. But there is still a problem. What is that problem is, there are 6 developers and each person is actually pushing 3 times a day. All 18 times, if one of the developer is actually trying to build the application, then that particular person will be working on deployment activities, not on the development activities. Okay, so that's the reason what we will have to do is we need to automate this process. So how do you automate this process? You automate this process by using Jenkins. Okay, I'll anyway show you this particular picture. little later. I'll come to this. Okay. But let's try to understand here. So what exactly this Jenkins does? Jenkins is actually CI/CD tool. I'll come to the CI/CD. Okay. But in the Jenkins, you create jobs. Okay, and why only Jenkins? Why not any other tool? Yes, you can use any CI/CD tool, but this is widely used tool, which is open source. That's the reason you will be learning Jenkins extensively. Okay, so using Jenkins, you create jobs. So what exactly job does? So jobs will be triggered by itself. Okay, when exactly it will be triggered? Like whenever any developer push the code, this job will be triggered. Okay, so in this job, you configure such a way that you first clone the code into the system wherever Jenkins is running. Okay, so now you have the code into the system wherever Jenkins is running. Fine. Or else in some situations, you will also clone the code in some other system as well. That's fine. So once you have the code, what you will have to do is you need to use the build management tool or project management tool. Okay, I am trying to use or teach this by taking Java as an example, an application. But it is DevOps is not tied to any one particular technology. You can actually use it for any other technology. It can be used for .NET, it can be used for Java, Node.js, Python, anything, doesn't matter. But I am trying to just explain by using Java. So for Java, we actually use a project management tool called Maven. Using this particular tool, okay, so what exactly we do is we actually compile the code. Okay, compile the code. So you already know what is compilation, converting your source code into mission understandable language. Okay, so once that is done, then after that, what do? You unit test it. Now let us try to understand what is unit testing. Unit testing is all about function testing, not the future testing. What do you mean by function? So when you are writing the code, there will be some functions. Let's say employee search is one of the function. What exactly it does? It will actually search the employees, and this particular function, let's say it is used in multiple pages of the application. Okay, now let's say you deployed into the production and actual users are using it, and after 2 months you will get an bug in one of the page. Then what will happen? In a hurry, and to fix that particular issue, or you are actually fixing this particular function. Functions are actually reusable components. Okay, reusable piece of code, I would say. So you have some code and you are modifying that particular code in that particular function. In a hurry, what do? You test only the page where exactly you found an error. But this function is used in other pages as well. In hurry, you don't test other pages and you just deploy it into the production. So then what will happen? You encounter problems in other pages as well. You may encounter. Okay, if that happens, it will be a problem, right? So that is the reason what people does is, our developer does is, they writes unit testing, unit test cases, I would say. This is actually a function test to test that particular function. Employee search, they create one more function. In that particular function, they will be calling this particular function with some inputs, and they'll expect some return value. If the expected return value they get it, that means it is working as expected, and all the possible scenarios they'll be writing it. They'll be having the test cases. For example, I'm taking a function called add a comma b just for simplicity, and it add two values, and I will actually write a unit test case by saying add 2 comma 3 and I'll expect 5 as a return value. If I get 5, then it is working as expected. Then other case would be, I'll say like add 10 comma 20, then I'll expect 30 as a return value. Then if it is working as expected, I'll say this is working as expected. So that's how it is. So like that, developers will be writing unit test cases, and that we call it as unit testing, and that can be added in this process. Okay. Now you have compiled it and you have done the unit testing and you generate the package. Now, as I mentioned, I am taking an example of Java. For Java, the packages will be jar, var, r, ear. What is that? So after compilation, let's say there are 100 Java files, and after compilation, you get like 100 class files, and then you need to share those files, or run those files as a one single file. Okay, if I have 100 files with me, I need to share it with you. Then how do I share it? I'll zip and send it to you, right? Okay, so instead of zipping, what we are trying to do here is we are actually archiving it. Okay, I mean, like you are generating the packages, I would say archive files, we call it as. Okay, so jar, var, or ear. So then you combine, you create it as one file for all those 100 files or 1000 files or whatever you get it. Then as a single file, you can run it. Okay, so that's the reason you generate these archive files. Okay, these we call it as packages as well. Then after that, you push this particular archive files into the repository. Okay, so into the artifactory, I would say. So it can be JFrog artifactory. So see, you are keeping the code in the Git, right? Like that, these archive files will keep it in the artifactory. That is JFrog artifactory. Okay, and from there you can actually take it and you can deploy it into related environments. So in this process, you do all this, and this process, when exactly it is happening, each time developer push the code. All this is happening. Okay, and if any issue comes in this particular process, you actually send a notification to the development team members. Okay, so this we call it as CI, continuous integration. Okay, now using that, first issue is resolved. Now developer need not to stay back. Okay, in the evening they are not trying to deploy the application once in a day. They are trying to deploy the application multiple times in a day, build the application multiple times in a day. Meaning each time developer push the code, they are doing it, but that too not manually. Now it is automated with the help of Jenkins. Now developers can actually focus on the development activities, not on the deployment activities, because it is automated. Okay, and that is, we call it as continuous integration. Okay, this is what it is. Developer commits the code and you have the code into the Git, and what Jenkins CI pipeline does, it will actually clone the code, then compile the code, unit test the code. And one more point here I'll have to mention is SonarQube. Okay, so this is actually code review process. For code quality, we actually use the SonarQube. Okay, so I'll mention here the SonarQube as well, so that in the end you will get to know what are the tools you will be learning. Overall, SonarQube. So why this tool is actually required is actually for the code quality purpose. Okay, so when you are working for a project, generally there will be different levels of experienced developers. One will have 2 years, someone will have 5 years, some other will have 10 years, like that, right? So you cannot expect everyone to write same kind of code. That is our performance oriented code. So that is the reason generally you review the code. Okay, who reviews the code? Architect or team lead will be reviewing the code. But reviewing the code line by line is difficult for anyone because we are into agile methodology. Okay, that's the reason. Why can't you automate that process also? So you can use this particular tool. In this particular tool, there will be some rules. Like for Java, there will be around 600 rules. For .NET, there will be around 450 rules. And using that particular rules, you review the code. And if there are any deviations, so that deviation will be captured in the SonarQube, and developers can log into the SonarQube and they can understand the issue and they can fix that particular issue. That's the reason that needs to be integrated in the CI process. Then you generate the artifact, then you push to the artifact. This process, we actually call it as CI pipeline or build pipeline. Okay, if any issue comes in this particular process, you automatically send a notification to the notification can be an email, it can be a Slack notification, and you send it to the developers. Then they'll fix that particular issue, and again the same process will begin. Once after fix it, then again our Jenkins job will be triggered. Then again this process will go on. Okay, that is CI process. Using that, the first issue is resolved, and for the second issue you do the same. You automate this process as well, meaning deployment, right? You have the package already in the Artifactory, which is in the JFrog. You take it from there. Then what do you do is, this we call it as CD, continuous delivery or deployment. And till now what was happening was, it was actually getting deployed into the dev environment. Okay, now what do? You actually put it into the QA environment with the help of one more job. Okay, it's not like in the Jenkins you can create only one job, you can create multiple jobs. And now what do? You try to deploy, and once everything goes fine in the development, then you will put it into the QA. Then if there are any automated test cases, then people usually write by using Selenium and all. Okay, automated test cases that can be configured over here. If everything is fine, automated test cases, then it gets deployed into the UAT. Okay, even on UAT, if everything goes fine, then you deploy into the production. Okay, but there is very important point we should understand here. I mentioned CD stands for continuous delivery or continuous deployment. Deployment meaning as soon as developer push the code, you deploy into the production, continuous deployment. But delivery meaning there will be a manual intervention. It is also deployment, but there will be a manual intervention. Okay, so what does it mean? As soon as developer push the code, you can't directly deploy into the production. Okay, the reason is that's the reason we have QA and UAT, and you need to take an approval from test manager, and you also need to take an approval from client and from UAT. Then only you will be deploying into the production. Otherwise, if you directly deploying it, there will be consequences. Okay, otherwise, one more point here you should understand is it not possible at all continuous deployment? Yes, it is possible, but it is difficult. It is not impossible, but it is difficult. If someone can able to write 100% unit test cases and 100% automated test cases, then it is achievable. But no one can claim that I have written 100% unit test coverage and 100% automated test cases. That is the reason 99% of the cases we actually use continuous delivery, not the continuous deployment. In the continuous delivery, there will be a manual process, and you need to take a permission from the test manager or from UAT, from the client, then only you deploy into the production. Okay, so but if once you get an approval, it doesn't mean that then you manually do it, but there has to be a job which just need to deploy it. Okay, that we call it as CD process. Again, in this process, if anything is not working, you stop deploying it, meaning it can be automated test cases. Okay, so or if you are not getting an approval or something from the test manager or from UAT, from the client, and you stop it, that we call it as CI. Okay, using the Jenkins, you can also achieve that as well. Using that, the operational team members issue you will be resolved, and they can again concentrate on their activities. Okay, fine. So that we call it as CD, continuous deployment. So the entire process is this one. Okay, so you push the into the artifactory, then download that artifact, deploy into QA, and use the Selenium test cases, and then you deploy into UAT if everything goes fine here. If it is failed, you notify it, then you deploy into the UAT. Then once user approves it, meaning like a client approves it, then you deploy into the production. If it rejected, then again you notify it, then you will be monitoring it. Thus we call it as CD pipeline, continuous delivery or deployment. Okay, so in this process you actually start with, while learning the tools, you start with Git, then you will be learning Linux and shell scripting. Then you will be learning Java and Node.js. So don't worry about Java and Node.js. I'm not talking about the coding part. I'm talking about whatever is required for DevOps that you'll be learning. Generally, outside people teaches only Java. I'd also include Node.js because for Docker and Kubernetes and everything, we need Node.js. So I'll come to that anyway, Docker and Kubernetes, but you will be learning Node.js. But after the course, if you are working on real-time projects with me, you will also get an opportunity to work on .NET projects as well. Then you learn Maven, then SonarQube, then Jenkins. You'll be learning it. Okay. And there are other tools also. I'll come back to that particular tools. And before I get into that, do you have any questions? Anyone? Any questions?
Yes, Prasad sir.
Yeah, Parmeshwar. Go ahead.
Sir, it is all are in Linux only. It's Git is also different now. GitHub is different or in Linux only.
Okay. GitHub is not tied to any one of the operating system. Okay. You can use either GitHub, Bitbucket or GitLab, but it is not tied to any one of the operating system. These are all central repositories, but Git, you can install it either in Windows or in Linux or in Mac, doesn't matter. It is platform independent.
You told no Maven life cycle now. This is a life cycle.
Okay. Maven
Maven.
is different than Git. Git is actually used for storing the code into the repository. Okay, push the code into the repository. But Maven is actually a project management tool, which is to compile your code, okay, and to unit test the code and generate the packages. So Maven is different, and Maven is used only for the Java projects, and Git is used for any of the projects, does not matter. Is that clear?
Yes.
Okay.
Where we have used jar where
Yeah, jar, var, EAR are actually for Java applications. Jar is actually for console or desktop application. Var is for web applications, and EAR is for enterprise applications in Java. But if you are using a .NET, you will be generating zip files or DLL files or executable files for .NET. It depends on the technology which you are using. So the packages differs. So if you are using Python, it may be different. Okay, it's not the same as Java, and you don't get jar, var, EAR in other applications or services.
okay, sir.
Yeah. But any other questions, anyone? Okay, fine. Let's move ahead. Thanks for your patience. I know it is a little longer, but still, like, we need that much of time. So I need 15 more minutes times. Okay. So that you will understand clearly what is the entire process and the tools which we'll be learning and the services. Okay. And there are other tools as well in the DevOps. But before I get into the DevOps, I want you to make you understand about the cloud platform. Okay. Yes. We will be learning AWS, but before we get into why are we learning AWS, let's try to understand what is cloud platform and why we should be using the cloud or learning the cloud platform. Okay, so I mentioned about the deployment, and where do you deploy? Generally in the servers. Okay. Server is also a system, and server generally will have like more capacity. That's it. So you are deploying your application into a server. Generally, you don't deploy your application in only one server. I'm talking about production. You generally deploy your application in multiple servers. Why you should be deploying it in multiple servers? Why not only in one server? The reason is, if that server crashes, then your application doesn't work. Okay. And not only that, let's say one server can serve only 250 requests per second, and you are actually expecting like 1000 requests per second. Then one server cannot respond to all the requests. So that's the reason what we will have to do is we'll have to deploy it in 4 servers, so that all those servers can share the load, so that the response will be quick. So that's the reason you deploy your application in multiple servers, not only in one server. Now let's say you are developing, or you have developed one application which is an e-commerce application, and you deployed that particular application in on-premise servers. E-commerce meaning using that website you are selling some items. It can be like mobile devices, accessories, all that, and you deployed it on on-premise servers. On-premise meaning company owned servers. And let's say you deployed your application in 10 servers, and you are expecting 10,000 requests per second, and one server can serve 1000 requests per second. That's the reason you deployed it on 10 servers. Everything is working as expected, but generally in the Diwali or any other festival, okay, so what will happen? There will be some offers. Okay, so at that time, what will happen? You are expecting more number of requests. If there are offers, yes, you will be expecting more number of requests. Currently, you are getting like 10,000 requests. Now, let's say you are expecting 20,000 requests. For 10,000 requests, you deployed it on 10 servers, but for 20,000, you need 10 more servers. And these 10 more servers, you need it only for 1 month. After that 1 month, you'll not be using those servers. And only for 1 month, buying those servers, and you need to have some physical space. If you are using like a 1000 feet room or whatever for 10 servers, you need the same again actually for 10 more servers. Then 24/7 you need to run those servers, and you need to hire 1 or 2 people to manage those servers, and you need to have security, everything you need it only for 1 month. And hiring a person only for 1 month is difficult. The reason is they charge more. First of all, it is difficult to hire a person only for 1 month, and also if you are getting it also you need to pay more. And there is one more important point here you need to understand is, how can you expect that only there will be 20,000 requests? It can be more or less, right? It can be 25, it can be 30, or it can be 15 also. So then you will end up provisioning more number of servers. That's a problem. So ideal number of servers by using on-premise, it is difficult to manage it. Okay, so that's the problem. That is the reason what I can do is I can actually use cloud. So cloud is like pay as you use. So for example, I am using the servers only for 1 month or 1 day or 1 hour. Only for that particular duration I'll be paying it, and I don't maintain that particular servers. Someone else will be maintaining it, and I get security, and I don't need any physical space. 24/7 I can run my application, and once I come out of it, I don't need to bother about those servers. It's like your cab, right? Any cab like Ola, Uber, whatever, right? So let's say I'm using my cab only for 1.5 hours. Only for that duration you'll be paying it, and you don't own that particular vehicle. And until you are using that particular vehicle, you feel secure. Once you come out of it, you don't bother about that particular vehicle. Same way, the cloud also works. And as I mentioned, the very important point, how do you predict the number of requests? So if you are using the cloud, there is a concept called auto scaling. Using that auto scaling, what happens is, if I am getting 20,000 requests, then you will be having like 20 servers. And if you are getting more, 25, 25, 15, 15 only. So what is the benefit you are getting it by using this? See, automatically the server count is getting increased or decreased based on the number of requests you are getting it. So what is the benefit you get it? If you are using more, pay more. If you are using less, pay less. But that cannot be achieved by using on-premise. This is very important point to be noted for the cloud. That is the reason most of the applications are moving to the cloud. Many of them are already moved, if not, are already getting developed in the cloud itself. But if not, like slowly, even they also move into the cloud only. Okay, that is the reason we are learning the cloud. And there are n number of cloud platforms. We have AWS, we have Azure, we have CenturyLink, Bluemix, GCP, so many are there. But why are we learning AWS only? First of all, no one is stopping you to learn other cloud platforms. If you learn one cloud platform, learning another cloud platform is very easy because many of the services will be similar. For example, in AWS, we will be learning something called EC2. In Azure, it will be virtual machines. Okay, EC2 are virtual machines only. So like that, services will be similar and the purpose also will be the similar. But these are all the leaders. First AWS, then Azure, then GCP. Okay, so but AWS is in the top. Fine. So that is the reason we are learning AWS. There is a reason for it because AWS only introduced this particular concept. So whoever is actually coming with a new idea, they'll generally be inclined towards that. For example, you take an example of Xerox. Xerox is just a company. But actually what we do, it's a photocopy, right? We don't mention it as photocopy. We always say Xerox. Okay. So like that, AWS also. Okay, so since they introduced this particular one, we are like many of the people are using it. But not only that, actually I have worked on like multiple cloud platforms, but for me AWS is intuitive. And there are other reasons to that. Anyway, we'll be understanding all that later. But as part of AWS, see, in AWS or any cloud for that matter, anything is a service. For example, you are launching one EC2 instance, which is a virtual machine. It's a service. You are using network, which is VPC. That's a service. And you are using a security, IAM. It's a service. Anything is a service. Okay. Now, what are all the services you will be learning as part of this particular course? So you will be learning all the services which are required for Solution Architect Associate AWS certification. I encourage you to do this. Okay, so definitely that will give you the weightage. So that is the reason. And I will definitely assist you if anyone is actually going for the AWS Solution Architect certification. And for them, I'll be taking separate sessions also. I'm not saying I don't cover here. If required, separate sessions also I'll be taking to them. Okay, and without any charge for that. Fine. And these are all the services you will be learning as part of this particular course. Okay, so EC2, S3 auto scaling, load balancing, RDS, EBS, okay, storages, VPC, FSX, IAM, Lambda, API gateway, ECS, ECR, Elastic Beanstalk, CloudFront, Kinesis, CloudWatch, CloudTrail, AWS CloudFormation, okay, WAF, fine. So Cognito, IAM under security. Okay, so all this you will be learning as part of this particular course. Okay, I teach everything I don't leave anything. Okay, whatever is required for solution architect associate, you will be learning as part of this particular course. Okay, fine. Now let me get into this one. Okay, any questions on AWS before I get into other DevOps tools? Okay, fine. Then as part of the DevOps, you actually learn Docker. So what is Docker? Using Docker, you can create containers. Using container, you can develop, deploy, and ship your applications. Develop, deploy, and ship your applications. Okay, so there is a difference between virtual machine and the Docker container. When you are using a virtual machine, you need an extra operating system. But when you are using a Docker container, you do not need an extra operating system. It actually uses your host operating system. So that is the reason for microservices, Docker is extensively used. And in the Docker, you will be learning Docker extensively. So you will be learning how to create a container, how to create an image manually, automation. Okay, what is networking in the Docker? Okay, Docker compose. Okay, Docker volumes, all that you will be learning as part of this particular course. Okay, so that's about Docker. Then you will also learn something called Kubernetes. This is container orchestration tool. So to manage your containers in a cluster, so whoever is actually from the storage, so definitely would be knowing what exactly the cluster is all about. So multiple servers together, we call it as cluster in a single network, which is actually a cluster and closely associated. So you are deploying your containers in multiple servers. If you're deploying it in only one server, if that particular server goes down, your entire application goes down. That's the reason you will put it in a cluster. And to manage your containers in a cluster, we need the Kubernetes. Very, 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 very important. So you will be learning Kubernetes as part of this particular course. Then you see something called Ansible. You will learn something called Ansible, which is actually configuration management tool. So what does it mean? What exactly it does? Let's say I wish to install Java, Maven, Tomcat, or copy one file, provide permission to one file and execute that particular file. If I am trying to do it in one system, I can connect to that system and I can do it. But if I wish to do it the same configuration in 20 servers or 40 servers, then it becomes difficulty. Okay, so first of all, it takes some time. Not only the time now, if you make some mistake and troubleshooting that particular issue also takes time, and fixing it takes some time. So that's the reason what you can do is you can use this particular tool, and you can will be writing something called playbooks with the help of YML script over here, and using that playbook, and there will be inventory. Using that, Ansible will connect to each and every system and it will configure it for you automatically. That is the reason we use Ansible, and it is a very important tool to learn. And then you will also be learning something called Terraform, which is required actually to provision the services. For example, I have AWS. So I wish to create one VPC, launch two EC2 instances, and have one storage. And I want to do this repeatedly. And I don't want to connect to the console and do it. Then how do I do it? So I can use Terraform and do it. Here we actually call it as IAC, infrastructure as a code. Okay, using this particular tool, what you can do is you can connect to AWS, not through the console. Okay, so through automation, through any one of the tool. From outside you can connect and you can actually launch all your services inside AWS. Not only in AWS, it can actually connect to any of the cloud platform, and it can configure it for you, and which is a very important tool to learn. Okay, so these are all the tools which you will be learning as part of this particular course. Okay, so from this beginning, like Git, Linux, shell scripting, Java, and Node.js, .NET, Maven, SonarQube, Tomcat, Jenkins, Docker, Kubernetes, Ansible, and Terraform. Then I already shown you the AWS services which we will be learning, and the duration of this particular course is actually 3.5 months, definitely. Okay, and initially I'll be starting with 1 hour, and later on it becomes 2 hours. Okay, so that's about it. Now, next week I am planning to start the new batch, which will be in the morning, 8 o'clock in the morning, 8 to 9, and then it may be like after few months, 1 month or whatever. I mean, I may take it either 7 to 8 or 9 to 10. Okay, so 2 hours the session will be there, either 7 to 9 or 8 to 10. So that's about it. Now I'm happy to take all your questions, and let me stop the recording, then I can take all your questions.